Okay, so the last test of this exercise 2.3. Ride along with me, okay? So here we're going to have the test here 2.3D. Okay, this will be exercise 2.3, question A 1 to 3. We'll find this on textbook pages 37 to 38, I think. Okay, 37 to 38. Right, likewise, and we'll start with it. So question A1 on page 37. Let me read the question for us. The polynomial which, when divided by minus x squared plus x minus 1, gives a quotient x minus 2 and remainder 3. So what is that polynomial we have to find? So here we clearly see a polynomial which when divided by, so this polynomial is divided by something. This polynomial, let us say p of x. In order to write this, p of x is divided by something means that required polynomial is on numerator, means it is the dividend. So the dividend is unknown. When divided by minus x squared plus x minus 1. So the divisor is g of x. We usually do not divide it by g of x. So since this particular polynomial is divided by minus x squared plus x minus 1, so that will be the divisor, right? G of x gives quotient. Quotient is, as we know by now, we're accustomed to it, denoted by q of x, quotient x minus 2. And remainder, and we know remainder is usually denoted by r of x, is 3. So we get given this 3 here, g of x, q of x and r of x, and we have to find that particular polynomial p of x. Now since we know by division algorithm that p of x, which is the dividend, is equal to divisor g of x into quotient q of x plus remainder, the division algorithm. So we're going to use that to find the unknown p of x here. So it will be a simple case of g of x here. Okay, g of x here minus x squared plus x minus 1. This one is the g of x, plus the bracket, into means I put another bracket, q of x is here x minus 2 plus r of x is 3. So let us do this and find out, simplify it. Now here, this is a trinomial, meaning it has got 3 terms, and here only 2 terms. So take the binomial, which is having 2 terms meaning. So binomial means a polynomial having 2 terms. So here lesser term, let that multiply this 3. So let us take this first one and multiply this x to all these 3 terms. Plus into minus is minus, x into x squared is x cubed. Then this one will multiply this plus into plus is plus, x into x is x squared, and then plus into minus is minus, and x into 1 is x. So this x has multiplied all these 3 terms. So now we go to the next term of the binomial. This one is the binomial. Binomial meaning having 2 terms. The polynomial having 2 terms is called a binomial. Okay, so minus into minus. Now this will now multiply like x has multiplied these 3 terms. So we will use this minus 2 to multiply these 3 terms. So minus into minus is plus, 2 into x squared is 2x squared. Then minus into plus is minus, 2 into x is 2x, and minus into minus is plus, 2 into 1 is 2. So this 2 has multiplied this, so we completed up to here. So next is a plus 3. Let's just go about it slowly and carefully. So since this is the only term having x cubed power, so I write minus x cubed. You can take it if you want. And here x squared terms, like terms, x squared. So plus 2, and here plus 1 will be plus 3. So this plus 1x squared plus 2x squared. You can take it is plus 3x squared. Okay, plus 3x squared. Then x terms minus x minus 2x. So minus 2 here and minus 1x means both minus means we add. So 2 plus 1 is 3, and when both are minus, we put minus after adding. So minus 1x minus 2x is minus 3x. All ticked means taken into account. Now this is plus 2 plus 3 is quite simple. Plus 5. So this is the unknown polynomial that we had to find, and we found out. So the answer choice in your textbook that match this exact one is the 2, 1 minus x cubed plus 3x squared minus 3x plus 5. So your answer is the 2, which is exactly this we found out, matching the one we found out by simplification. So A1 is done. Now let's go to A2. Okay, A2. So A2 here. Let me read the question for us. For what value of k the polynomial p of x equal to 2x cubed minus kx squared plus 5x plus 9 exactly divisible, so keep that in mind, exactly divisible by x plus 2. So here, let us assume that p of x be the given polynomial, or not let, but it's already mentioned. P of x means the dividend, usually dividend is equal to 2x cubed minus kx squared plus 5x plus 9. Now since p of x, this one, is exactly divisible. The word exactly divisible means, it simply means there will be no remainder, or in other words, the remainder will be 0. Exactly divisible by x plus 2, the textbook says that. So one value of x is, since this is exactly divisible by x plus 2, one value of its 0 will be here. See, when we took here minus, if x value is minus 2, then we factor, one of the factor will be x minus the root, the 0. If 1 0 is this one, then we're going to get here minus and minus plus 2. What we're saying is that this x plus 2 has come about because one of its zeros is minus 2. Definitely, so therefore I'm going to write one of the value of x here, p of, definitely one value of x is the opposite sign of this plus, minus 2 will be equal to 0. Okay, why? Because we know this by remainder theorem. Okay, when it is exactly divisible means remainder is 0, then the divisor, okay, one will show the one of the roots or zeros of the, or one of the zeros of the polynomial. So the 0 is here, plus 2 means its 0 would have been minus the opposite sign, so I put here minus. Had it been minus, I would have put here plus, because had it been minus, then minus into minus, x minus, whatever is the 0 we put, and we would have got x plus 2. Okay, sorry, had it been minus, okay, oh sorry, had it been plus, sorry, had it been plus, then x minus plus 2, and our divisor would have been x minus 2. I hope you're getting it right. So here now, so by remainder theorem, definitely one of the roots is minus 2, so p of putting the x value minus 2, one of the value will be equal to 0. So that implies p of minus 2, you can just p of minus 2 therefore means this one here. See, take this one, 2 into x value is now minus 2, so you put here minus 2 whole cube minus k into x value we're taking as minus 2, the whole thing square, plus 5 into x value here minus 2, so I'll put in there, plus 9. will be equal to 0. Then you continue solving. Just keep this one and solve with the inside one. Minus 2 cube means minus 2 into minus 2 into minus 2 3 times. Simple case, minus into minus, plus into minus, minus. So 2 2s are 4, 4 2s are 8. So it's going to come out minus 8. So minus 2 cube is minus 8 because the power is odd. So the sign will remain minus. Then here, don't multiply now, just keep the k outside. And here, minus 2 square means minus 2 into minus 2, which is minus into minus, plus 2 2s are 4. So this will be plus 4. Square is dealt. So plus. Okay, now you can do this one. This is fine. There's no power here. So plus into minus is minus. 5 2s are 10, plus here 9, equal to 0. So that gives you here plus into minus is minus 16, 2 8s are 16. K into 4, minus into plus, minus k 4s are 4k you can write. Minus 10 plus 9 is minus 1. You can write like that. Minus 10 plus 9 means minus plus, so subtract. 10 minus 9, 1. 1 borrowed, so no more. Bigger one minus, so this one also will have minus. So that's why minus 10 plus 9, I wrote minus 1, is equal to 0. Then here, minus 16 minus 1. We know that when both are minus, we add. So this will be 17, and both are minus means after adding minus sign. So minus 16 minus 1 minus 17. Then here, minus 4k is equal to 0. This 2 minus 17 minus 4k. I think this, yes. So now we're going to get here minus 4k. Just keep it like that and shift this minus 17 to right side, become plus 17. We don't want to keep the left side here having k minus, so we want to change to plus. That's more convenient. So if you change minus 4k to plus, the other one, the sign will change. Plus 17 will become minus 17. Just flow closely, it's quite easy. Okay, next step equal to here. That implies k is equal to, then 17 is having minus, so with minus 17 by this 4 into, if you shift right side, will come the denominator. So these are value for k, and the answer choice matching this k value is 2, which is minus 17 by 4. So A2 also done. One more last question. Okay, so let us do that. A3. After that, you can give this test 2.3D. Okay, so A3. Let me see here, A3. Okay. The degree of the remainder when a cubic polynomial is divided by a quadratic polynomial. So A3. So for this, let's say here, first case, let cubic polynomial be equal to x cubed plus 3x squared plus 3x plus 1. Now what is a cubic polynomial? A polynomial of degree 3 is called cubic polynomial, meaning if the highest power of the variable, normally x, is 3, not higher than 3, not lower than 3, then that's called a cubic polynomial. The highest power of x among all this is x to the power 1, 2 and 3. So this whole thing is a cubic polynomial because the highest power of x is 3. And now divided by quadratic polynomial. So quadratic polynomial means cubic means highest power is 3, quadratic means highest power is 2. So this will be, I'm choosing intentionally here a first case where x squared, let us say plus 2x plus 1. I know that when this cubic polynomial is divided by this quadratic, now this is quadratic because highest power is 2. So x squared, quadratic polynomial, exactly divisible I'm taking. So this is a case when, okay, when exactly divisible. We have to take both the cases for exactly divisible and when it is not exactly divisible. Now we know that exactly divisible means this divisor and quotient. Okay, these are such that when you divide, the remainder will be 0. So In fact, the divisor is a factor of the dividend. This is the dividend. When the cubic polynomial is divided by quadratic polynomial, means cubic is the dividend and quadratic polynomial is the divisor. So I choose a cubic polynomial and a quadratic polynomial, which may not be exactly same to mine, but the condition should be same in the first case, where the cubic polynomial that I have chosen is exactly divisible by the quadratic polynomial that we have chosen, meaning there will be no remainder. So intentionally you have to choose a cubic and a quadratic polynomial such that they are exactly divisible. Then what happens? You can try dividing. Now you can see here. So question clearly says the degree of remainder. What is the degree of remainder when cubic polynomial is divided by quadratic? So cubic is divided by quadratic. So cubic will be inside, meaning cubic will be the dividend. And we're going to check. And divided by quadratic means quadratic will be outside. Okay. So to divide, we know that we have to take the highest degree term of the dividend and divide it by the highest degree term of the divisor, which is x squared. So on cancelling, 3 minus 2 power is 1 left, so x to the power 1, which we just write as x. You can write that. So first term of the quotient here is going to be x. X into x squared is x cubed, plus into plus x into 2x is 2x squared, plus into plus is plus, x1s are x. When we change the sign of the lower terms, plus becomes minus, this plus also becomes minus. That way our intention is to cancel out this minus x cubed plus x cubed is 0, so it vanished. Then plus 3x squared, and this has become minus 2. So subtraction, because plus minus and bigger one plus, so here also plus. So in other words, plus 3x squared minus 2x squared will be plus 1x squared, which is simply written as x plus x squared. Plus 3 and here minus 1, because it has changed to minus. So 3 minus 1, 2, bigger one plus. So plus 2x plus 3x minus 1x is plus 2x, in other words, plus, we write this one. Now still the degree of the dividend here, x squared, is same to the degree of divisor, and according to division algorithm, so we have to continue dividing, because we have to bring it to a point where degree of the dividend becomes lower than the degree of the divisor. So it's not yet lower, they are equivalent, degree 2, degree 2. So take the highest degree term of the new dividend by the highest degree term of the divisor, and everything cancel means 1 left. So I'm going to write here 1 means plus 1. So 1 multiply this, 1 into x squared plus 2x plus 1 into 1, 1. Change the lower terms sign of the lower terms rather, minus plus become minus, plus become minus, plus become minus. And we see here that minus x squared plus x squared 0, plus 2x minus 2x 0, minus 1 plus 1 0, so remainder is 0. Proving that we have chosen a cubic polynomial and a quadratic polynomial such that the quadratic polynomial exactly divides the cubic polynomial. So means no remainder, and it's correct. So this is the case. That is, in other words, the degree of remainder. Now you see here, I've taught this in one of the earlier class. If it's constant numbers like 0, 1, 2, 3, 7, 13, whatever, the degree of such a polynomial is degree 1. If it is x plus 2, highest power of x is 1, then it is degree 2. If the highest power is x squared plus x plus 2, let us say, then the degree is 3. So since 0 is a constant, so the degree of the remainder, which is 0, is going to be 0. The remainder is 0, we know that, but I'm not saying here remainder is 0, I'm saying degree of the remainder. Degree of any constant number is always 0. Numbers are, constant numbers are in at other times otherwise called 0 polynomials, 0 degree polynomials. So the degree is coming out when they are exactly divisible. The degree of the remainder comes out to be 0, which is less than the degree of the divisor. Degree of the divisor is 2 here when it's quadratic. so it's lower. Then let us take the next case. Next case is not exactly divisible, so you can put here now case 1 if you want, that's better. And case 2. Case 2 is when they are not exactly divisible. So let us take here a cubic polynomial should be divided by x cubed plus 5x squared plus 6x plus 1. I'm consciously choosing a cubic polynomial and a quadratic polynomial, x squared plus 2x plus 1. I've already checked before, and so you have to do likewise. Your examples need not be same as mine, but it should be same with mine in the sense that we should consciously choose a cubic polynomial and a particular quadratic polynomial so that they are not exactly divisible in this case, and in this case they are exactly divisible. Okay, so we have taken a cubic polynomial this time, highest power 3, and a quadratic polynomial highest power 2, such that the remainder will not be 0. First we have chosen is for remainder 0 and found out in such a case the degree of the remainder, which is 0, is 0. So let's see what is the degree of the remainder when we choose a cubic polynomial and a quadratic polynomial such that they are not exactly divisible. So here you write the condition for choosing these two is not exactly divisible. That means you're going to get a remainder greater than 1, greater than 0, sorry. Okay, not when p of x is not exactly divisible by g of x, or not divisible p of x. Okay, you can just put here. So you can specify also. You can go and insert something. So since cubic is divided by quadratic, so p of x will be the division p of x, and divided by quadratic means quadratic is the divisor, so g of x. So likewise, you put here also cubic polynomial is divided by quadratic. So let the cubic be mentioned as p of x, because p of x usually denotes dividend, and quadratic polynomial divides the cubic, so it will be the divisor g of x. So when, okay, so you can write here a little bit more specific if you want. When p of x, that means dividend, is not exactly divisible by g of x. Okay, so here you can specify, this is also okay, but you can specify more detail. When p of x is exactly, that means the dividend, cubic polynomial p of x is dividend, exactly divisible by the quadratic g of x. Okay, g of x. So when it's not exactly divisible, p of x is not exactly divisible by the g of x, means cubic is not exactly divisible by g of x. Let's try the division. P of x is a dividend, so it should go inside the division sign here. X cubed plus 5x plus 6x, 5x squared, sorry, plus 6x plus 1. Okay. Then the divisor is x squared plus 2x plus 1. So x squared plus 2x, x squared plus 2x plus 1. Start dividing. So here highest degree term of the dividend is x cubed divided by x squared. So these two cancel, 2 minus 1, 1 left, so x is left. Write this on the graph. First term of the quotient will therefore be x. So this will multiply with these three terms. X into x squared is x cubed, plus into plus is plus, x into 2x is 2x squared, x into 1 plus 1x, or simply you write x. Then put a dash, change the lower sign, plus become minus, plus become minus, plus become minus, so that this 2 will become 0. Plus 5, and here minus it has become, so subtraction. 5 minus 2, 3, bigger one plus, so plus 3x squared. Then plus 6x minus 1x will be plus 5x. I think you understand this, so I won't show that like this, okay? then here plus 1. Then here highest degree term still x square, highest degree of the new dividend is 2, degree of the divisor is 2, and division algorithm tells us that we have to continue dividing till the degree of the dividend becomes lower than the degree of the dividend or the remainder, okay, that you got becomes lower than the degree of the divisor. So in exactly speaking, degree of the remainder becomes lower than the degree of divisor. Still it's not lower, still same, degree 2, degree of this new remainder is degree 2, of this one the divisor is also degree 2. So as long as they are equal, you have to continue dividing. So take the highest degree term of the new dividend, which is actually the remainder from here. So 3x squared divided by highest degree term of the divisor. So this 2 square cancel means plus 3. So the next term will be plus 3. Okay, so here you multiply that to all the 3 terms here of the divisor. 3 into x squared, 3x squared, plus into plus, plus 3 2s are 6x, and plus into plus, plus 3 1s are 3. So now it's a matter of changing the signs of the lower terms. Plus become minus, plus become minus, plus become minus. Minus 3x squared plus 3x squared 0. Minus 6x plus 5x is minus 1x. Minus 3 plus 1 is minus 2. So remainder, the degree is now x to the power 1 means degree 1. Degree of the divisor is 2. So the remainder, degree of the remainder has become lower, degree 1, than degree 2, that of the divisor. So degree of the remainder has become lower than the degree of the divisor, means we have to stop. So we should not further divide. So according to division algorithm. So now that means the division is, the remainder is not 0, as you can see, this one. So in such a case, that is here, we can see, in this case, degree of remainder is equal to, degree of remainder is equal to, here remainder is minus x, minus 2 means highest power of x is x plus 1, so degree is 1. So question is saying, when you divide a cubic polynomial by a quadratic polynomial, cubic by a quadratic polynomial, as you can see in both cases, then what will be the degree of the remainder? Degree of the remainder in the first case was 0 when it was exactly divisible. Degree when it is not exactly divisible is degree of the remainder is 1 when you divide a cubic polynomial by a quadratic polynomial. So we can club these two conditions and search our answer. Therefore the degree of remainder could be 1 or less than 1. So degree is 0 in the first case. So your final step is, therefore degree of remainder can be 1, as you can see here. When they are not exactly divisible, when a cubic polynomial is not exactly divisible by a quadratic polynomial, the remainder is going to have degree 1 all the time. And when it is exactly divisible, it is 0. So that means it will not go beyond 1. So degree of remainder can be 1 or less than 1. So can be equal to 1 or less than 1. This is the total condition. As you can see, 0 degree is 0, degree is 1 when it is not exactly divisible. So the degree do not cross or go beyond 1. So you can say when a cubic polynomial is divided by a quadratic polynomial, whether in the case of exactly divisible or not exactly divisible, the degree can be from 0 to 1 but cannot go beyond 1, means it can be highest 1 or lesser than 1, means 0 is also lesser than 1. So you write there which condition is having 1 or less than 1. First one is saying less than or equal to 1. Okay, less than or equal to 1. So that is the one. So the right option is the one which is saying the degree of the remainder will be, this is called lesser, this is called lesser, this is called greater. Lesser or equal to 1. See here. It is less than 1. Less than 1. Or can be 1 means equal to 1. Equal to, see here, equal to 1 or less than 1. So less than or equal to 1. So first one is the answer. You can see the wrong choices also, greater than or equal to 1. It cannot go greater than 1. Exactly 1 when it is not exactly divisible. a cubic polynomial is divided by a quadratic polynomial when remainder is not 0, that time the degree is 1 but does not go beyond 1. When it is exactly divisible, the degree of the remainder is 0. So it was not going beyond 1, and choice number 2 is saying can be greater than 1, so that's definitely false. Third one is equal to 2. It cannot go beyond 1. We've checked and found out. Greater than or equal to 2 cannot go beyond 1. So clearly 2, 3 and 4 are wrong choices. The first one is the right one. It can be less than 1, as you can see here, 0 when it is exactly divisible. It can be equal to 1 when the remainder is not 0. The degree of the remainder is always 1 when you divide a cubic polynomial by a quadratic polynomial. I hope you got it. Okay, so that'll be completing the part for this test. Okay.